So hello everyone, this is Code Runner, and in this video I am going to explain this question, that is maximum rectangle area in an histogram. So we have given so we have to find the largest area possible in a histogram. So we have given an array, and these elements of this array simply represent the all bars with the we can say, and width of each bar will be 1 unit. So and there are n bars, means n is the size of an array, and these are the heights. The element of we can say element of array is the representing the height of the bars. So let's discuss with this test case. Let's understand this. So so for example, if I have taken this test case, that is n equal to 7, that is n equal to 7 that is n equal to 7, and uh, there are 7 bars, and each of height are, and this arrays this element of array, these are representing the heights of the bar. So we need to find the maximum area between these bars. So we have to find the maximum area, and each bars have breadth 1 unit. So yeah, there is the breadth of the each bar will be 1 unit, and there are n bars of each height. Each bar will be given by the array of, that is, elements. So we need to find the largest area. Mm, we need to find the largest area enclosed between these bars. So for example, in this test case, so the first bar will be of height, that is 6. This is 6. Next, that is 2. In next, that is 5. This is 2. This is 5. This is 5, and this is 4. This is 5. This is 1, and next that is 6. This is 6. This is 1. This is 5. This is 4, and this is at index 0. The height of the bar is 6. At index 1, the height of the bar is 2. At index 2, that is, the height of the bar is 5. Index 3, index 4, index 5, and index 6. So simply we have to find the maximum area between the, we can say, between these bars. So how can we find the these maximum area? So for example, each we have each breadth of each, we can say, each bar will be one unit. Okay, so this is 2. So if I have to find the maximum area of each bar, then I have to find the maximum area covered by that bar. So for example, if I have this bar 2, so I will see the maximum stretch of this bar can be, I can say, so this will be the reason. So this is the reason. This is the maximum area. So how will we calculate this? Simply we will, what we will do simply, that is 4 minus, that is 4 minus, that is 0, minus 1, that is 3. 1 2 3, yeah, that is 3. Okay, in this question, the intuition behind this question is we need to find the maximum area, maximum size of histogram of, we have to simply find the maximum size of histogram, and maximum size means we have maximum area. So for 6 the maximum area will be this region, that is 6 into 1, that is. So how we will find? We know that area of histogram is equal to the, that is area of histogram is equal to the, that is length into breadth. So length, length is equal to the, that is height of each bar. So length is represented by the, that is array of, we can say each element of array is representing the height of each bar. For example, this 6 has the height, we can say this bar 0, the first bar has height 6. So ARR of 0, that is representing the height. So height will be, we will get the height from this, that is from the AR, that is from array, and we need to find the breadth. Okay, we need to find the breadth. So how can we find this breadth? So let's see the simple logic, how we can find the breadth of this, we can say maximum, we can say breadth of the, how we can find the breadth of the, these these histograms. So for finding the breadth, we need to look after the, we can say next nearest smaller left element, or we can say we have to see the nearest left element, or we have to see the nearest smallest right element. So so in left index there will be, there is no left index, so this is minus 1 index, and after the 6 there is no index, so this is index 7 that have value 0. This is also have value 0 because these, there is no histogram in this region. So how we will build the intuition? So simply we have, we need to find the, how can we find the breadth? So we need to find the nearest smallest, we can say nearest smallest right index. So simply we can find the breadth by simply nearest smaller right, nearest smallest right index minus nearest smaller left index minus 1. This will be the formula for, we can say, finding the breadth. So nearest smallest, so first of all we have, we will find the, so in the first step we will find the, that is nearest smallest right index. So I will take two arrays. The first one is representing the, that is NSR, that is nearest smallest right index. So this is index 0, this is the index 1, index 2, 3, 4, 5 and 6. So this is index minus 1, that is, this is 0. So for, we have to find the smallest nearest right element, so right index, sorry, index. So for for 6, is there is any we can say nearest smallest index. So this is this, that is 2 nearest. So smallest index will be 2 has index 1, so we need to store them in the this array, that is NSR. So I will store 1 in this we can say in this vector, that is NSR, which is representing the nearest smallest index on the right side. So after that we'll find the nearest smallest index of 2, that will be 1, that will be 5, which is 1. So we need to store it on this, and after that we'll look after the smallest index of we will look for the 5, and we will look that smallest index of, we can say 5, that is 3, that is 3. After that 4, that have also index 5, that has the smallest index 5, and for 5 there is same, that is index 5, there is a value smaller than 5, that is 1, nearest value smaller than 5 is 1, and that has index 5, so we need to store them in this. So this is 0. So after that, so this 0 has this 0 is less than 1, so we need to store the index of this 0, that is 7 and 6. So in right side we have this 0 that has index 7. So this is the array which is representing the nearest, we can say smallest index to the right side of this histogram. Now we have to find the nearest smaller index towards the left side. So this will be the NLR. So this will index 0, this will index 1, this is index 2, this is index 3, this is index 4, this is index 5, last that is index 6. So for, and that is index we can say for 6 there is, that is this smaller value, that is we can say less than that is 6, so its index is, that is -1. So we need to store it on in this vector, that is NLR, that is representing the nearest we can say nearest index to the left side. And for 2 also, nearest we can say we have to find the nearest smallest index towards the left side. So this will be also -1. For 5 there this is 2, that is 1. For element 5, the smallest element towards right is 2, and that has index 1, so we need to store it on the vector, that is NL NLR vector. And after that we have to see to the this 5. So and after that we have to look after the 4. So for 4 also there is only the nearest index will be 2, sorry, nearest values will be 2, and it has index 1. And 5, that is for 5 there is nearest smallest value, that is 4, that has the index 3, so we need to store them, that is 3. And for 1 the nearest will be, that is -1. For 6, also the nearest, we can say nearest will be 1, that has index 5, that has index 5. So let's we can say dry run this, dry run this that is NLR vector. For example, if I have 6, then it has nearest smallest value, that nearest smallest index, that is -1. For 2 is also -1. For this 5 there is 2, that is has index 1. 4 also there is index 2, and 5, for 5 there is 4, that has index 3. And for 1 that is -1. For index that is 6, at index 6 that has 6, and that has nearest smallest value index, that has, we can say, 5. So yeah, this is correct. And now what we have to do is simply we need to find the width, array. So we need to simply subtract these values, and we will get the this width vector. This is index 4, this is index 5, this is index 6. So there is 1, that is 1 plus 1 minus 1, that is 1. In next, that is 5, that is 5 plus 1 minus 1, that is 5. After that, that is 3 minus 1, 3 minus 1, that is minus 2. 3 minus 2, that is 1. For 5 minus 1, that is 4, minus 1, that is 3. 5 minus 3 minus 4, that is 1. In next, that is 7 plus 1 minus, that is 7. 7 minus 5 minus 3, that is 1. Now we have we can say we have getting this, we have calculated this breadth vector. So now we have to with this breadth array, now we have to simply, what we have to do for area, we have just calculated the breadth array, and we have to we have the height, that is ARR of I, that has particular, for index I, that has particular height. For index for for example, if we need to find the height of this we need to find the area of this bar, that is 6. So simply, that is ARR of, that is 6 into 1, So area, so maximum area covered by that is bar, that is 6. Next, that is 5. So AIR that is 2 into 5, that is 10. So this is 10. So 6, 10. In next step, that is 5 into, that is ARR of this 2, that is 5. 5 into 1, that is 5. 4 into 3, that is 12. 5 into 1, that is 1. 5 into 1 is that is 5. 1 into 7 is 7. 6 into 1 is 6. So we have to find the maximum of these resulting we have resultant array. So we need to find the maximum area between these. So we have find it this we can say area covered by each bar. So we need to find the max of these. So max of these will be, that is 12. So the desired output will be 12. So this is the whole intuition. So we can say simple logic behind this question is simply what we are doing here is simply we are looking for the nearest greatest element, because we need to find the we can say maximum, we can say the maximum the bar can expand from to the left side of each, we can say from left side or right side. So we need to find the minimum, because if we need to find the minimum we can say minimum element, so that the maximum this at particular index, that bar will be expand to the right to its right and to its left up to its height. So we need to find the minimum, we can say minimum of these indexes. So we are so first of all we are looking for the minimum, you can say minimum element at minimum index at the left side, and right side we are subtracting this, we are getting the array we are getting the area between these bars. So for example, in this case for 2 there is smallest element will be to the left side, that is -1, and right side what will be the minimum, that is 5. So 5 minus minus, that is plus -1, that is 4, that is 4, we can say that is 5, and 5 and its height we will multiply it into its height. We have find it the breadth, now we have to find the height. So height is given to the height is given, that is 2, simply the 10. So yeah, this is the step we are following. So simple logic behind simply here simple logic is we have given we can say we have provided the height, and we need to simply find the width of the each histogram, we can say. So we need to simply find the breadth of the each histogram, and we can find it by finding the minimum index to the left of this we can say particular bar, and for right side and for left side we need to find the minimum index at the left side. So that will be the maximum area covered by this bar. So simply how can we do this question? Simply, so we will take the help of the stack for finding the, we can say finding the nearest smallest index to the left side and right side. We need to use the make the we need to use the stack for we can say finding the nearest index at the left and right side. So we will simply take an that is stack, and we will put we can say we will for example, if we have this array, for example we have this array. So we have this array. So for finding the, for example, I'm finding the nearest smallest index to the right side. For example, I'm finding from the right side. Okay, so I'm finding from the right side. So I need to push the element from the opposite direction, because this we can say that is stack is based on the leaf of principle, that is last in first out. So if we see, if I need to compare the, we can say this element, if I need to compare the top element, so we need to I have to insert it from the inverted side, we need to I need to insert this from the back side, because it will be come at the top. If if I insert this from this side, then this will be this 2 will be goes in, we can say, at the end of the stack. And how I can this compare this? So we need I need to we can say insert the element from the back side, so that the top element will be its adjacent element. So what I will do, if stack is empty, I will simply insert this into our stack. If our stack is empty, I will simply, yes, I will maintain an array that is representing the NSR, that is nearest smallest indexed to the right side. So this is index 0, this is index 0, this is index 1, this is index 2, this is index 3, this is index 4, this is index 5, and this is index 6. So for 6 there will be no element, we can say no element to the right side. So we need to simply return the -1. So we need to simply return the -1. Okay, after that we will check for the this index 1. So I will check for this is now we will insert this 6 into our stack, and our top element become this 6, and we will compare from this one. If this is less than, we can say, if this is less than we can say less than the top element of the stack, we need to store it on our this vector, and we need to push into that stack, that is 1. Now coming to the this fifth index. So I will be storing the indexes of this we can say smallest element. So this has index 0, this has index 1, this has index 2, this is index 3, this is index 4, index 5 index 6. So for 1 there is for 1 there is no element smaller than that, so we need to simply put -1. After that, for 5 we will compare this with our stack and we will see if this is smaller, then we need to store them in the vector. So we will simply understand it with the help of the code. So let's jump through the code in we can say GFG editor. So we will understand with the help of the code. So this is full code. So simply we need to find the maximum area. So simply we are following this step. The first step is simply we need to find the breadth array, and breadth array is we will find the breadth array by simply looking for the nearest smallest element to the right side minus nearest smallest index to the left side -1. So we have taken two vectors. First vector will store the nearest smaller element to the right side, and the second vector will be storing the nearest smallest index to the left side. So after that we have simply initialized our maximum sum variable with the int min, because we need to find the maximum. So after that we have iterate through this we can say whole array, and we have simply calculated by simply this is height and this is breadth. So simply updated our max variable and simply return that. So how can I find the nearest smallest element? So I will simply explain one function. So other will be same, but but the loop we can say insertion of these element into the stack will be in opposite direction, because we need to find the nearest smallest to the left. For in the case of we can say we need to find the smaller nearest smaller left element indexes. So we need to iterate from 0 to n. So simply I have taken the pseudo index, that is -1, and I have taken an vector which has this and I am taking the values in pair. We can say the first value will represent the nearest greatest element, and second will be storing the we can say indexes. We are taking this into pair because we need to compare with this value, and value of each we can say value at each index, and we need to store the index. So we need to simply compare the element value, and we need to store them with the indexes. So I have taken the it in pair, that is long of time log long, and after that I have iterated through the whole array, and simply I am comparing the top element, that is so simply I will explain the concept of pair. So in C++ we have this container, that is pair, which will store which will help in storing our we can say pair values. For example, if I have to store two values along with the indexes. For example, I have to store the sum at each index along with the sum of each element along with the indexes. So I will be using the pair. So here the pair will be taking the two values, that is of any type. So here we are using the int comma int. In this case we are using the long, so we will take long here. And how can we can access these values? So we can access this value by simply this will be the, for example, this is pair P. If I have to access this first value, then how can I access this first value? That is P dot first. That is P dot first will give me this first value, and this P dot second will give me the second value of the pair. So by we can say by writing P dot first will give me the access to the first variable in the pair, and the P dot second will give the access to the second variable in the pair. So we are taking the help of pair in this case, because we need to compare the value and we need to store them, store the indexes of each values. Along with the value we need to store the indexes also. So we are comparing with the top element of the stack with the our array. If it is less than, if it is less than our array, then we need to simply push that element into our stack, and if it is greater than, then we need to pop the remaining element, we can say, into from the stack. And yeah, if stack is empty, we need to store the pseudo index, and after that we need to return the we can say this vector, that is nearest left, smaller left, and nearest smallest to the right. So this will give the our desired output. So this is, we can say, easy question, but you need to recognize the pattern, we can say. So that's all this in question. So thank you for looking for this question. So I will meet you in the next section of this explaining the questions in the topic that is stack. So thank you for watching my video.